All right. So for the second part of it, it's going to be a little bit of reasoning there. Okay. So if you just look at number 2, you can see that a 4-digit number, ABCD, is divisible by 9. All right. So ABCD divided by 9 has a remainder 0. Now it says that ABC is also divisible by 5 and 9. So first of all, it means that C is equal to 0 or 5. And also, if ABC is divisible by 9, it means that A adding B adding C is a multiple of 9. Now, ABCD is also divisible by 9, which means that A adding B adding C adding D is also divisible by 9. So let me just write it down, if you can see the relationship between those. Now, comparing these two expressions, you can see that if I know that D is either going to be 0 or D is going to be 9. All right, so it means that now actually we have just, well, a few different possibilities right there. So let's move on to see if we have any more clues. All right, let's move on to see if we have any more clues. Oh, it also says that it has 4 different digits. Okay, so it means that CD is going to be equal to 0, 9, or 50, or 59, right? Okay, and also it says that the 2-digit number AB is divisible by both 3 and 4. 3 and 4. So it means that A adding B divided by 3 has remainder 0. So now, this is interesting. If A adding B divided by 3 has remainder 0, we can see that ABC and ABCD, they are both divisible by 9, which means that A adding B adding C divided by 9, divided by 3, let's say, put it in the same scope. If it is divisible by 3, it is definitely divisible by 9, right? So, now I have this list. A adding B divided by 3 has remainder 0, and after adding C to A and B divided by 3, it still has remainder 0. After adding D to it, it still has remainder 0. Which means that C cannot be 5. Right? Because if I am adding 5 to a multiple of 3, after dividing 3, it's going to have a remainder 2. It's not going to have a remainder 0. So C is not 5, which means that CD can only be 0, 9. CD can only be 0, 9. Now, if that's the case, it means that A and B added up must also have remainder 0 when divided by 9, because CD adds up to 9, right? So if you're replacing that with a 9, it means that AB adding 9 divided by 9 is remainder 0. And if I take away the 9 from A, B, and 9, of course A and B, what's remaining, also has a remainder 0 when divided by 9. So it means that AB divided by 9 has remainder 0. And AB divided by 4 also has remainder 0. Which means AB is going to be a common multiple of 4 and 9. So AB can be 36 or AB can be 72. Which means that the 4-digit numbers are possibly just 3609 or 7209. All right, so these two are the possibilities. Does it make sense?